Hi, my name is Luca DeJean, and this is going to be my Fluids first project. So we're going to begin by creating a fluid flow with Fluent inside of our workbench, and we're going to just begin by opening up geometry. Once we're in here, we're going to go ahead and change it to the Z-axis, just so we can get that 2D reference. And we're going to go up to the top here and sketch. Make sure we're on sketch mode. And create a rectangle starting at the origin just because it'll make it much simpler. And I'm just going to make a regular rectangle like this. And then I'm going to go up into here in constraints, click dimensions, click from here to here, set that there, and then from here to here, and set that up here. And from here, I'm going to be using the length of 150, which is what I was told to do in the instructions. So it depends on exactly what you're told. And I've found that the height of 3 millimeters has worked very well for me in order to just make it simpler and find everything correctly. Then we're going to select up in here, using the box, select this whole area, so we'll have our whole shape here, and we're going to be able to fill it. Once it's filled, double check that you have the right measurements on each side, and make sure that it's become shaded in right here inside of the area. Then you're going to be able to go back to your workbench and click onto the mesh. And for this one, we are making a Poisson. Just wait for mesh to load. Once inside of mesh, we're going to go ahead and click on our Z-axis and zoom out so we can see everything. And we're going to go ahead and click up here on edge, just so we can click this edge right here, right click, go to insert, and, oh, sorry, you're going to go to create name section. So you're going to click that, and we're going to name this our upper wall. Make sure the apply, okay, click OK, and then we're going to click our lower wall and do the same thing. Then our inlet is going to be right here. Just name that inlet. This will make this easier just later on. So go ahead into here, click create name selection and outlet. From here, we're going to make sure we're clicked on the edge, or you can click Control E, and we're going to go into mesh, right click, insert, sizing. Then from here, we're going to be control clicking the top and bottom. So the top one and the bottom one. And then go into geometry, click apply, change the element type to number of divisions. And for my personal use case, I'm going to be voting 750 because that has just worked perfectly for me. And then we're going to change this capture curvature to no and this behavior to hard. From here, we're going to click generate, wait for it to finish meshing. And this is pretty much going to create our mesh for our in between our upper and lower walls. Then we're going to right click on mesh again, click insert again, click sizing again, then control left click the inlet and the outlet. And then you're going to go over here and click apply, then go into elements, change this to number of divisions. Number of divisions for me that works well was 100, though this can depend between you and your exact size, and it really does depend through people, but just for this use case, we're going to be using 100. Change this capture curvature to no and behavior to hard. Next, we're going to make sure we're clicking on this, click generate, wait for this to finish meshing real quick. Perfect. Then we're going to double click on mesh and click on this inside of mesh. You'll see we'll click on this face meshing. So once you click on this, make sure, perfect. We're going to click apply on this geometry. So make sure you click it and then go into apply. And then from here, we are going to generate. And this generate might take a little bit longer. Oh, perfect. So now you should be able to see when you go onto mesh, it might be all black like this. But when you zoom in, you'll see that it actually has created these tons and tons of sections throughout the pipe, so that you're throughout this surface, sorry, so that you're able to measure in every single one of those pieces. So once we finish this, we're going to double check everything's good, our mesh is good, our name selections are all here. We have edge sizing 1 and 2 and the face meshing. After this, we're going to exit out and go back to our workbench. Now you might need to update this. Sometimes that's what needs to happen. But once you see that check mark on the mesh, check mark on the geometry, we're going to go right into setup. And make sure in here that you click double precision. I'm just going to start this. Might take a little bit. And in here, we're going to be able to see on this right side our mesh that we have created, as well as you can see the inlet and the outlet. There you go. Sorry. Then from there, we are going to see that our, one second, sorry. Now we're going to be able to see inside of here, we're going to go through and we're going to go to models and change this viscous to laminar, because that's what we're looking at today. We're looking at laminar flow. Then, since this is a Poisson flow, we're going to be going out of models here into materials, and for my use case, I utilized air, and my constant here, I'm just going to change this to 1, and then I'm going to change this to 1e -6 as my viscosity constant, just because that's worked for me, but it may change between your use cases and my use case. Make sure you click change and create, then you're going to close this. Then we're going to go just check this, make sure it's air in here. Yep, perfect. Apply and close. And then we're going to go into our boundary conditions. So for this flow, the inlet actually has a velocity. So in my use case, I found that 3 worked very well for my velocity. So this was in comparison, and this can really change between your height and length, and as well as your viscosity and density. So I'm just going to click apply here, close here. Internal outlet is still going to be the same, but in outlet, we want to go in here and prevent reverse flow, and just click apply and close that out. And since this isn't a co-et flow, we're not changing anything with the walls. They should both be just completely stationary walls. So both of these should be both completely stationary walls. And as we can see here, they both have non-slip and are both stationary. After this, we can go right into the bottom here where, oh, and first we want to make sure we go into results, residuals, and change this to just have add as extra 0 here. Click OK. And then we're going to go into initialization. Click initialize. Once it should get to 10 around here and say that it's done. Go to run calculation. And in here, we're going to be putting the number of iterations. Just to make it a little bit quicker to render, normally I would do from 300 to 500 iterations, but here I'm just going to do 100 just to make it easy and able to be seen very easily by us. Then we're going to go down to here, click calculate, and it might take a little bit. You can go ahead and see right here it's meshing as well as the residuals, and should get it right here up to 100. So this is just measuring all of the iterations. And there should be a little thing soon that's going to pop up and say that our calculation is complete. Perfect. So once you go here, we're going to go back to the workbench, and you may need to close a couple other tabs just to make it easier for your computer to see. And in this, we're going to see the results. Click here. Right into here, we're going to go into our outline here and make sure we're clicked on that z-axis. And so we're going to be able to see all of this. And in here, we're going to want to start by creating our lines. And these lines are going to be where we measure for information for our charts and everything like that. So since I have a line of 150 millimeters, and this is all in meters, so we need to change that. Make sure you convert it correctly. And then here I'm just going to take that midpoint, which is going to be 75 millimeters, and then we're going to have a height of 3 millimeters. Make sure you change this to 100 samples, and you should click apply. You'll see that little line pop up right here on the right side. Next, we're going to click line again and do an end line. So for an end line, we're going to go into here and put it as close to the end of your surface as possible, but not exactly on the end of the surface, as this could create some issues just with graphs and its turbulence. It's better to just put it not exactly on the end. So in here, we're going to click in here and make it a height of 3 millimeters and make sure our samples are at 100. Once we have our midline, our end line, now we're going to put a line where it is still a developing flow. So you'll be able to see this exactly in the graphs, but I'm just going to put this at 0.001, and I might change this a little bit later just to make it easier for y'all to see. And we're just going to go into here and make sure we're at a height of 3, and make sure we take 100 samples. And you'll be able to see our 3 lines here at the beginning, here in the middle, and 1 at the end. After this, we're going to want to go into our default legend view and change this to horizontal. And in here, we're going to want to change this, make sure it's fixed, not scientific, fixed. Then we're going to go up here, click contour, contour 1 is fine, and change it so that the location is symmetry 1, and our variable is velocity u. And we're sure we're going to take 110 contours. So in here, you'll be able to see, once I click apply, takes a little bit to load, and now you can see our flow as well as this little legend for our contour. Next, we're going to want to go up into here and click create graph. So this insert chart is going to be able to show us what we see on that contour diagram. And it's really used in order to create a create a profile for it. So then we're going to want to go into the in the general and change our title to the velocity profile for flow. Perfect. And then make sure we're on XY line. And then here we're going to want to add 3 series. So our first series is going to be our midline. Second series is going to be our end line. And then third series is going to be our developing flow. And then we're going to want to make sure the location on here is developing flow, location on here is end line, and location on here is midline. Perfect. Then we're going to want to go into the x-axis and change this into velocity u. Our y-axis will become the y component. And just make sure in here everything's good. Okay. And then we're going to go ahead and click apply. Now we're able to see in this chart how our end line flow is, which is fully developed, our midline flow, which even though it may seem developed, is not actually entirely fully developed, and then we can see this developing flow. And it's really how it's first beginning with those no slip conditions that it really changes everything. And once you're here, if you need to export any of this information, you're going to go down here in the left and click export, and you'll be able to export it wherever you need to. So now that we're back on our workbench, this is going to be our Poiso flow. This is the new one that I just showed y'all how to do. Oh, sorry. And so this is the new one that we just made. And for these next two, for the Couette and Hybrid, the geometry and mesh, it's going to be exactly the same steps. So we're just going to go right into the Couette setup. And this is going to be my setup, but I'll still show y'all exactly how to do it. And yeah, I'm just going to go into here. Make sure this is double precision always, and then going to click start. So if with a Couette flow, we know that it is the top plate moving. So that is the real difference between the Poisson and the Couette flow. So we're going to want to go into, oh, once it loads, might take a little bit. Still loading in. Perfect. So what we're going to want to do is go into here, make sure our viscous is laminar. Click OK. Then in our materials, make sure our fluid is air. And make sure for this one, I used a constant of 1. And for my viscosity, sorry, for the density, and then for my viscosity of 0.001, because that's just what works for me, but it can depend on every use case, and every person has a different experience with it, especially if you're using a different size and things of the sort. Then we're going to want to go into here, make sure it's air still. Yep, perfect. Then in our inlet, we're actually going to be changing it from a, sorry, we're actually going to be changing it in here. So you're going to want to right click, type, and normally it is a velocity inlet, but we're going to want to change that to a pressure inlet. So once you change that, you're going to make sure you want to go into here and prevent reverse flow. Click apply, and then go down to our outlet. Click in here. Make sure you click prevent reverse flow, and then apply and close it. And then for this, our lower wall needs to be no slip and and be stationary. But on the other hand, our upper wall, the one that's moving, needs to be a moving wall like this. And then in here, you want to make sure that you put your speed. For me, my speed was 3 meters per second. That's just what worked for me. And make sure your shear condition is no slip. Gonna click apply, close, go down into here, click initialization, initialize it. Should get up to the number 10 here. And then run calculation. For normally I do 500 iterations, but just so that it's a little bit faster, I'm just going to do 100. We're going to click calculate. And then from here, we're going to see it all display and wait for that calculation is done. Perfect. Calculation complete. So once we're here, we're going to want to go back to our workbench, make sure we have a check mark next to our setup, and go down into results. In results, we're going to be doing something a little bit similar. And that's going to be, here, I'll unclick them just so that I can show y'all exactly. And I'll just remake them. So we're going to want to go into location, line, and create a midline. Click OK. Yeah, I'll just make it a midline 1. Okay. And then here, same thing is going to be 0.075, 0.075, and then here it's going to be 0.003. And then make sure we do 100 samples there. Click apply. You're going to see that pop up. And then we're going to want to also make an end line for this. So end line 1. Okay. This one's going to be, remember, at 0.499 for me, but remember to put it right before you actually have the end of your surface. Here's going to be my same height, and you can see these pop up on the right side here. And my samples are just going to be 100, just like the other one. Click apply. And then for this one, we're going to want to make a contour again. And make sure in here, our legend view, it's horizontal and fixed right here. So instead of scientific, fixed. And then we're going to want to go into contour. Click here. Click OK. location is going to be on symmetry 2 just so we can see our lines. And our variable is going to be velocity u. And make sure our contours are 110. Then we're going to click apply, and we're going to be able to see this flow that the top plate creates, with it actually increasing as it goes up towards the plate, kind of in a linear motion, which I'm about to show you in this graph. You're going to want to create this chart right here, go into data series, make sure we put our two series. So here's going to be our midline at the midline, and then our end line at the end line. Perfect. And we're going to want to go into x-axis, velocity u. Y-axis is going to be y. And we're just going to want to click apply here. And we're going to see this very linear, very one slope chart. And this is exactly what we want to see, and it's what's expected, as we can see in this 3D viewer. It increasing in speed with our legend. We're able to see that it's increasing in speed very linearly. So once we're done with this, if you need to export the information to an Excel, you can go in here, make sure you do a CSV, and you'll be able to get your files if you need to find a exact max velocity or minimum velocity. And this is our chart. And then once we're done with this, we're going to head right into our hybrid flow. So same thing as the Couette flow. I'm just going to show y'all through the setup and results, as our geometry and mesh are exactly the same as the Poisson. So we're going to head right into the setup. Make sure in here we have double precision, and go ahead and click start. Just going to wait for this to load. Takes a little bit of time. Oh, perfect. And now we can see our flow and our surface and our inlet and outlet. So beginning with every single time, we're going to go into here, go into viscous, and make sure we're on laminar. So normally it starts on K epsilon or K omega. Just make sure you're on laminar. Next, we can go ahead and close these models and head into materials. So we're going to be using our fluids, and it's going to be air. So my constant for density was 1 per usual. My viscosity for this one, I did have to lower it to 0.0001. And this was just for my use case, but it may depend on your use case with the size or the exact dimensions of your surface. So we're going to close this, Make sure in here we have air. Perfect. Then in the boundary conditions, our inlet, even though it is a pressure inlet in some sort of ways due to the hybridness, we still need a velocity inlet, so it can be a Poisson as well. So for my velocity, I decided to go with a velocity of 1 meter per second. That's just what worked for me. And we're just going to click apply here and close. Then on the outlet, we want to go into here and make sure we have prevent reverse flow. Click apply, click close, and then click on this wall. And our lower wall, we want to go into here. Since it's not going to be moving, we're going to make it a stationary wall with no slip condition. Click apply, click close, then go into the upper wall. And in here, since this one is moving, we're changing it to a moving wall with no slip. And the speed that worked for me was 0.7 meters per second, but it can change with what you are doing with your dimensions. I'm going to go into here, click close, go into initialization, initialize it. Make sure we get to that 10, hybrid initialization done. And then we are going to run calculation. Just to make it a little bit faster, I'm going to go to 100 instead of 200 or even 500, but we're going to go ahead and click calculate. Wait for this to calculate through, and then we'll be able to go into our results and see once this is complete. Perfect. So we're going to head back to Workbench and go to results. Should be a check mark on everything. Check marks, check marks. So we're going to go into here, results, and so let's check it out. So in here, we're going to make sure we click on the z-axis, and I'm going to go ahead and unselect my previous work so I can show you exactly how I got here. So we're going to start by creating a line, and this line is going to be our midline. Click OK. Oh, midline 1. And our midline, per usual, is going to be 0.75. 0.75 for my dimensions, but it can change for your dimensions. Just make sure it's right in the center. Make sure we're at 100 samples, and we are going to click apply. Next, we're going to make our end line, and go into here, 0.75, 0.75, 0.003 millimeters. Or sorry, 0.003 meters, which is 3 millimeters, and 75 millimeters. And 75 millimeters, as well as 100 samples. I'm going to click apply. Going to be able to see this all pop up onto our screen. And with this, our end line one and our midline one should both be there. Right here. Oh, sorry, my end line is going to be 1499 because it is right before the ending of my block. Perfectly, we can see it pop up there, that midline there, and then we're actually going to also make a underdeveloped region. And for this, I did the same thing, location line, created my underdeveloped region at the 0.02. So this is going to be 20 millimeters into my surface and a height of 0.003 meters, so 3 millimeters, and make sure we have 100 samples on there. Just going to go ahead and click apply. So now that we have our end line, midline, and underdeveloped region, we're going to want to go into contour. So make sure you go into here first, into default legend view. Make sure it's horizontal with a fixed, not scientific, fixed precision. And we're going to want to go into contour. So once we're in contour, make sure we click symmetry 2. Our variable is going to be velocity u, and we're going to want 110 contours. We're going to click apply, and we're going to see that pop up with our contour. And as you can see, it is similar to a Poisson flow, but you can see it's a little shifted up. So we're about to check just in the graph to make sure we get all of our values. So inside of our chart, we're going to title this we're going to be able to title this the velocity profile for hybrid flow. Data series, we're going to want to make sure we put all of our series in here. So this is going to be midline at the midline. This is going to be our end line at the end line. And this is going to be our underdeveloped region. We're just going to go our underdeveloped region. Perfect. Our x-axis is going to become velocity u, and our y-axis is going to become y. Go ahead and click apply. We should be able to see this chart pop up, and this is exactly what we want to see with our flows and our end line, midline, and our underdeveloped flow. So with this, now that we have all this information, if you need to, you can export it here and get all of your values that you need. And yeah, once we're done with this, we can go ahead and head into the paper where we are putting in our information and our Poisson flow, where we have the vector lines and as well as the contour, our profile where we calculated for the maximum velocity and the maximum velocity height just inside of Excel, and using that export feature. And then our density is going to be 1 here, and then exactly how we saw in there, our descriptions. Then for our Couette flow, same thing. We're going to have our contour with the profile, as well as our maximum velocity, which ends up being 2.97 meters per second, and our maximum velocity height of 2.97 millimeters. And with this, our hybrid one will have a maximum velocity of 0.91 meters per second and a maximum velocity height of 0.73 millimeters. In this, we were able to see our Reynolds number be 30 for the hybrid, which is still inside of the 2500 needed for a Blame-It flow, as well as 9 in the Couette, which is still inside of the 2500, and 1.34, which is still inside for the Poisson flow for a laminar flow. And then we can put our equations used down here, and that's it.